Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Irham ID. We will teach you about the group 2 in the periodic table. So I'm gonna start with the electronic configuration of group 2. But before that, we have to know what is the group 2 elements, or the other name is alkaline earth metals. So alkaline earth metal have two electrons in their s orbital. So what are the elements in the group 2? The elements in group 2 of periodic table is magnesium, beryllium, calcium, strontium, barium, and radium. The electronic configuration of beryllium is 1s2, 2s2. For magnesium is 1s2, 2s2, 2pc, 3s2. And for calcium is 1s2, 2s2, 2pc, 3s2, 3pc, 4s2. So that, as you can see here, all of them have two electrons in their outer shell. So they must lose both electrons to get a stable electronic configuration. So they can readily lose the outer shell electron to form positive ions. Next, as we down the group, number of shell is increased, Sheldon effect is increased, atomic radius is increased, and the first ionization energy is decreased. As the nuclear charge increase, the electron go into shell that further from the nucleus, so that it has tendency to lose two electrons to form two positive cations. So that's all from me.
Next, I will share about the physical properties of group 2. Number 1. Group 2 are less reactive than group 1. Number 2. Group 2 elements are metal. Number 3. They are relatively high melting point and boiling point. Number 4. They are all conductor of heat and electricity. Number 5. They are green, silvery solid at 298 Kelvin. Number 6. They are ductile, malleable, and soft. Number 7. They are more dense and harder than alkaline metal. Why group 2 elements get more reactive? The reactivity of group 2 element increase down the group.
This is because by increase in ease at losing two outer electrons as we descend the group, the loss of electron become easier due to the decreasing ionization energy required.
Group 2 element consists of barium, magnesium, calcium, strontium, barium, and radium. So now we are going to discuss or learn about the chemical property of group 2 elements. Now we are going to learn about the oxide of group 2 element. We look about the preparation first. There is only two types of oxide of group 2 element, which are monoxide and the peroxide. The group 2 element does not form superoxide. This is because if the cation is too small, it is very difficult for enough peroxide or the superoxide ion to cluster around it to form stable crystalline structure. When we react group 2 element with the oxygen gas, monoxide of group 2 element is formed. Only barium can form peroxide when we react with oxygen gas. In the lab, we can form the monoxide of magnesium or the calcium by using the reaction of thermal decompositions of carbonate, hydroxide, and the nitrate of magnesium and the calcium. Before we learn about the reactions of the oxide for the group 2 element, I just want to ask every one of you, do you still remember that what is the name for the group 2 element? The answer is alkaline of metal. Since the group 2 element is alkali, so this means the group 2 element can react with acid. So the first reaction is the group 2 element react with mineral acid. For example, the hydrochloric acid, nitric acid, and the sulfuric acid. The second reaction is is react with anhydride acid. What is meant by anhydride acid? Anhydride acid is a kind of acid without the hydrogen ion. For example, the CO2, SiO2, and the P2O5. But the barium oxide in the group 2 element is very special. Barium oxide is amphoteric, so this means the barium oxide can react with base, for example, the sodium hydroxide. So now we look about the preparation method for the hydroxide of group 2 element. Barium hydroxide and magnesium hydroxide is very special. We have the specific preparation method. For the barium hydroxide, we use the barium chloride and also the sodium hydroxide as the reagent. And also the magnesium hydroxide, we use the magnesium sulfate and sodium hydroxide as the reagent. For the preparation of the hydroxide of the other group 2 element, we have two methods. The first one is dissolve the metal in the water, and the second one is dissolve the metal oxide in the water. So next, let us learn about the reaction of the hydroxide for the group 2 element. As mentioned before, group 2 element is alkaline. So that means the hydroxide of group 2 element is also alkaline. So the hydroxide of group 2 element can react with mineral acid and also the anhydride acid. For example, the CO2. When the hydroxide of group 2 element react with CO2, carbonate of group 2 element is formed. But if the CO2 is in excess, the bicarbonate of group 2 element is formed. And please don't forget that the barium hydroxide is same as the barium oxide, which are also the amphoteric. So that means it can react in acid or react in base. So now we move on to the carbonate, the preparation method for the carbonate of the group 2 element. All of the carbonate in the group 2 have their own specific preparation method. The first one, the barium carbonate. We react the barium hydroxide with the CO2. The second one, the magnesium carbonate. We react the magnesium nitrate with the sodium hydrogen carbonate. You may notice that other reaction is used sodium carbonate. Why the magnesium need to use the sodium hydrogen carbonate? Do you know the reason? This is because if we use the sodium carbonate, the hydrolysis of sodium carbonate will produce more basic solutions. So we will get basic magnesium hydroxide, magnesium carbonate. This is not the product that we want to. So we need to use the sodium hydrogen carbonate to get the magnesium carbonate. For the calcium carbonate and also the strontium carbonate, both need the sodium carbonate to prepare. The reagent is calcium chloride and the strontium sulfate, respectively. The last one is barium carbonate. We use the barium sulfide, the CO2, and the H2O. Do remember that the carbonate of group 2 element is alkaline, so this means it can react with mineral acid. And last part is the sulfate. The preparation of sulfate is quite easy. We just need to react the halogens of group 2 element with the sulfuric acid. So now we move on to the halogen. The general preparation method for the halogen is the metal react with the halogen. But for the chloride of group 2 element is more complicated. The first we look about the anhydrous first. For the barium and the magnesium, we react the metal oxide with the carbon and also the chlorine gas. But for other group 2 element, we need to use the hydrated chloride salt. We need to heat it to get the anhydrous chloride salt of other group 2 element. But this method cannot be used for the magnesium. For the magnesium, we need to heat the hydrated magnesium chloride in the flow of HCl so that we can get the anhydrous magnesium chloride. Okay, the second part is the hydrated part. For the hydrated part, we react the metal oxide with the chlorine hydrochloric acid so that we can get the hydrated chloride of group 2 element.
Besides, I would like to point out the diagonal relationship between berylliums and aluminiums. Berylliums and aluminium having a more similar atomic radius and electronegativity. This causing the pair of atoms arise diagonal relationships. Some of the properties of berylliums are more similar to the property of aluminium than those of group 2 elements. Beryllium ions have a small atomic size with a high charge density. This property gives beryllium a high polarizing power, causing the beryllium ion can distort the electron crowd of the adjacent anions. So, beryllium compound with high covalent characters. The anomalous properties of berylliums are beryllium chloride is a covalent compound, while other group 2 chloride are ionic compounds. At room temperatures, beryllium chloride exists as a dimer, which is soluble in non-polar organic solvent. The oxide and hydroxide of group 2 elements are basic, but beryllium oxide and beryllium hydroxide show ephedrite characteristics. This indicates that these ionic oxides have significant covalent characteristics. The beryllium ions is small in size by having a high charge, so beryllium can form complex ions such as theta hydroxyberylate anions and theta fluoroberylate anions. The other group 2 elements rarely form complex ions. Lastly, I would like to talk about the application of group 2 elements. Group 2 elements consist berylliums, magnesiums, calciums, sodiums, berylliums, and radiums. First, we talk about the berylliums. Metallic beryllium is mainly used in radiation window of X-ray tubes due to its high permeability to X-ray. When beryllium being combined with copper, it will form copper beryllium alloys. This alloys is used in the manufacture of high-strength spring. The next element is magnesium. Magnesium powder is high tolerance for heat, making it to be used in heating elements. It is widely used in flash powders, bulbs, and lighting signal. When magnesium hydroxide dissolves in water, it forms suspensions. It is used in treatment of antacids in medicines. Also, magnesium is widely useful in preparations of various alloys, such as magnesium aluminium, magnesium zinc, and magnesium tin. For an example, magnesium aluminium is light and tough metals. It can be used in aircraft constructions. For calciums, calcium oxides and calcium hydroxides are used as agricultural limes to neutralize acidic soils. Calcium sulfate is used as fertilizers and soil conditioners. Because of calcium hydroxide with low toxicities and mild basic properties, it is also used in food industry such as sugar industry and processing water for beverage industry. The next element is about sodium. Sodium is used for producing glass of cathode ray tube for color television. We also use sodium in producing finite ceramic magnet and in refining zinc. The next use is about beryllium. Beryllium is mainly useful in beryllium sulfate. Beryllium sulfate is used as permanent white in paint and as a whitener in photographic paper. Besides, barium chloride and barium nitrate is the ingredient to generate the green color in fireworks. Other use of element beryllium is about beryllium carbonate, which is used as a red poison. Lastly is the radium. Radium stores are used in radiotherapy for treatment of cancer. That's all from the Group 2 present. Thank you.